This video is brought to you by Altium 365, where the world designs electronics, and Octopart, the fastest search engine for electronic parts. I have already made many videos on ESP32 CAM. If you haven't used the ESP32 Camera Module before, I highly recommend that you watch my getting started video, because in that video I have discussed the issues related to ESP32 Camera Module, and I have also practically demonstrated how to solve those issues. In addition, I use the ESP32 CAM as a smart IoT doorbell, in which I created a cell phone app with the help of the Blynk application, which I used for monitoring the camera, and at the same time I used it to control the door lock. I have also used the ESP32 CAM with Google Drive, and a lot of people like that project because with the help of this project you can monitor your camera from any corner of the world, provided if the internet connection is available. For more ESP32 CAM related videos, check my playlists. You may have noticed that there is a micro SD card slot by using which you can store images in it, and this way you can make a time-lapse camera for yourself. I have already explained the time-lapse camera function in the Google Drive video. In today's video, I will use this long-range adjustable IR sensor with the ESP32 camera module. I have taken this IR sensor from DF Robot. I will share the complete specification of this IR sensor with you guys. Well, if you guys don't have this IR sensor, you can use a simple push button for testing. I connected the IR sensor with the ESP32 camera module as per the circuit diagram, which I will explain later in this video. First, I'm going to explain its working, and then I will start practical demonstration. Before using the camera module, you have to insert the SD card into it. Then you have to install this IR sensor and camera at the place which you have to monitor. As you can see, there is quite a long cable with this IR sensor, so you can easily install it at your desired location. For demonstration purposes, I will check this project on this table so that all friends can easily understand its working. You can see I have powered up the ESP32 camera module. Now, if any object or person comes in the range of this IR sensor, ESP32 CAM will automatically capture its picture and will save it in the SD card. So let's go ahead and start our practical demonstration. Altium 365 lets you hold the fastest design reviews ever. Share your designs from anywhere and with anyone with a single click. It's easy. Leave a comment tagging your teammate and they will instantly receive an email with a link to the design. Anyone you invite can open the design using a web browser. Using the browser interface, you are able to comment, markup, cross-probe, inspect, and more. Comments are attached directly to the project, making them viewable within Altium Designer as well as through the browser interface. Design, share, and manufacture all in the same space with nothing extra to install or configure. Connect to the platform directly from Altium Designer without changing how you already design electronics. Altium 365 requires no additional licenses and comes included with your subscription plan. Get real-time component insights as you design with Octopart built into Altium 365. Octopart is the fastest search engine for electronic parts and gives you the most up-to-date part data like specs, data sheets, CAD models, and how much the part costs at different amounts, etc. right in the design environment, so you can focus on your designs. Links to the Altium Designer, Altium 365 and Octopart are given in the description. You can see the ESP32 CAM successfully captured all the images and saved them in the micro SD card. I'm sure by now you might have got an idea of how does this system work. So without any further delay, let's get started.
Access granted.
The components and tools used in this project can be purchased from Amazon. The components purchase links are given in the description. I have got this long-range adjustable IR sensor from DF Robot. On the front, it has got the transmitting and receiving IR LEDs. On the back side, you will find this red color LED which lights up each time the sensor detects anything. Next to the LED, you can see this small screw which you can use to adjust the detection range. The blue wire is the signal wire, the brown wire is the voltage wire, and the black wire is the ground wire. The output form is PNP, normally open. The signal type is digital. The operating voltage is 3 volt to 5 volts. Due to such a wide input voltage range, it can be used with all 3.3 volt and 5 volt compatible controller boards like ESP32 CAM, Arduino, ESP32, ESP8266, STM32, etc. The detection range is from 0 to 200 cm. For more technical specifications, read my article. I will provide a link in the description. Now let's take a look at the circuit diagram. The circuit diagram is very simple. The signal wire of the IR sensor is connected with the IO12 pin of the ESP32 camera module. I have designed this simple development board for the ESP32 camera module. You can see I have added these male and female headers for connecting the 5 volt power supply and for connecting different types of sensors. If you want to make the same development board, then you should watch my previous video. I will provide a link in the description. You can download this code from our website electronicclinic.com. I will provide a link in the description. Uploading code into ESP32 CAM is a bit tricky. You will have to connect it to the Arduino to upload the code. You can follow these connections. For detailed explanation, read my article. Anyway, after uploading the code, I connected my IR sensor with the ESP32 camera module and I powered up the ESP32 CAM using a 5 volt regulated power supply. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode and thanks for watching.